So everything we did up to now in the chapter was dealing with expressions. I mean, it was simplifying expressions, sometimes multiplying, simplifying, dividing and simplifying, but everything was simplifying expressions. But this is the section that gets at solving equations. In every chapter, there's going to be some part of it which is, simplifying expressions. And some part of it will be solving equations, and the last part will be graphing functions of that type. Right? The graphing of functions type we don't get to until the next testable unit. It is at the very last section of the chapter. But this is, the objective is, okay, we're going to learn how to solve radical functions or radical equations. And when they put in a thing like this, verify possible solutions to an equation, it kind of sounds like what they're saying is, given a multiple choice format, would you be able to figure out which one of those answers was correct? So they're kind of at one step saying, learn to solve them, but you may be able to just back substitute and figure out which one is right. Good. So to solve radical equations, these steps are really close to the same steps we use for absolute value. For absolute value, you isolate the absolute value, you break it down, you undo it or break it down in a way different depending on whether it was equation greater than or less than. This one, what we say is undo the radical, meaning it'll be different depending on what the radical is. I mean, if we have a square root, we'll undo it by squaring both sides. If we have a cubed root, we'll undo it by cubing both sides. So what we do at that step, will just depend on what we've got. Once we've undone the radical, we'll have an equation that we ought to be able to solve. Something that's an equation that's like a type that we've already solved up till now. And then there's always the possibility to check. But just like absolute value equations, the truth is that a lot of these, the checking is a nice step. It's always good to check your answers. But there's some in particular that you really have to check because extraneous solutions are possible. So we just see when is it that we might get an extraneous solution. So these steps are right here. So this first one, okay, what does it mean to isolate the radical? Okay. Yeah, you want it to be the only thing on that side of the equal sign. Just kind of like isolating x when you're solving an a simple algebra equation. In that problem there, what do we need to move? The 3. How are we going to move it? Subtract 3, right? So now we've got the square root of 2x minus 3 equals 5. Okay. Have we isolated the radical? Yes. Okay. Now, how do you think we would undo a square root? Square both sides, right? So the undo, it depends on what you've got, because we know we could have infinitely many combinations of radicals, but this is a square root, so and I'm going to show this as another line, right? I mean, I could just do it right there, but then I wouldn't see that right there. So let me do it on another line. I'll go parentheses. The square root of 2x minus 3 squared equals 5 squared. Okay, what do you get when you square a square root? Say again? They cancel each other, right? That's why we did it, right? The square of a square root is what's inside. And 5 squared, 25. Okay, so that was the undo the radical part. Okay, now we have to solve the equation that's left. And this is a linear equation. Pretty basic procedures for this. What should I do? Plus 3. And divide by 2. right? So that was the solve. Okay, the check part. The check part means let's go back into here, plug in the 14 and see whether you get the right answer. 3 plus 2 times 14 minus 3 equals 8. 3 plus, okay, 2 times 14 is 28, minus 3 is 25. And 3 plus 5 equals 8. That's a check. You know, if that answer doesn't check, it's not because it's extraneous. It's because you did something wrong. Yeah. Where? Here? Here? But just take the square root of 25. Right? Just like here, we 5 squared to get 25. Here, we took the square root of 25 and we got 5. Okay. So, let me try it again. What do I need to do here? Plus the 5s. And then undo it. How do I undo a square root? Square both sides. So now we've got 4x plus 1 equals 25. Four x equals 24. X equals 6. That problem's too similar to the first problem. Check. So try the same thing with that one. What you get? 2? 2? X is 2? I mean, again, you know, in a multiple choice format, 2 would have been one of 4 possibilities, maybe 5, right? And you plug it in. You know, you could probably have just done this by inspection. You know that this has to equal 2. So it's a square root. It's got to be the square root of 4. So what do you add to x to make 4? It's got to be 2. 2 plus 2 is 4. Right? But if we go through the steps, go ahead. If we go through the steps, it would have been the square root of x plus 2 equals 2. X plus 2 equals 4. x equals 2. Right? Not too hard. Okay, well, sometimes they're not written as radicals. They're written as rational exponents. Right? But if you are okay with what we did in the homework last night, I mean, you could always just convert it to the radical form and then do what we just did. Right? So these steps are mostly the same. It just, because it's not going to be, the problem's not going to be written as something that has a radical in it. It's going to instead have the exponent, which is a fraction. Then you take a step and make it a radical, and then follow the same steps. That's probably the cleanest way to do it. You could just stand there. Thank you. Right, so this will be just one added step to the other steps that we already have. Okay. So, for example, in this one, convert to the radical form first, meaning just this part right here, this x plus 1 to the 2/3. How do I write that as a radical? What would be the index of the radical? 3, right? And then what goes inside? X plus 1 squared. So that's converting that to the radical form. You still got the 3 outside, and it equals 12. But by taking that first step, now you're basically following the same steps that we did before. Now isolate the radical. What am I going to do to isolate the radical? Divide by 3, right? Divide 3, divide 3. So now we've got the third root of x plus 1 squared equals 4. Okay, we're up to the third step. Undo the radical. How do you think we would undo a cubed root? Cube it, right? Cube both sides. Okay, again, what do we get when we cube a cubed root? They cancel each other out, right? So you're just going to get what's inside the radical, right? That's why we did it. X plus 1 squared equals 4 to the third. You're right. 64. Okay, now, so that was the step of undo, right? Now we got to solve that. And what kind of equation is that going to be? What will be the highest power of x? It's squared. It's a quadratic. So when you're thinking of how you're going to solve it, you're going to have to think to solve it like we solved quadratics. And, you know, you have options. At the very least, I mean, this is what they would expect you to do. If you got x plus 1 inside parentheses squared, then take the square root of both sides, right? That'll get us to the what's inside here. We're undoing a square now by taking the square root, right? And that gives us x plus 1. Oh, darn it. There's the x plus 1. Equals, what square root of 64 is? 8. But it's actually not just 8, because this is where this is, you know, I tried to make this point at the beginning of the chapter. When you take a square root because you're solving an equation, you got to use the plus or the minus. If you are presented with a square root, you assume it's the positive. But this is the case where we use the square root to solve, so we need to say plus or minus 8. I mean, how many answers do we expect to get from a quadratic? We expect to get 2, and that's why the plus or minus. We wouldn't get 2 answers if we didn't have that. So now I still haven't solved for the x. I have to subtract 1, right? So this will be -1 minus 1. This is x equals -1 plus or minus 8. So what are the 2 values of x? -1 plus 8? 7. And -1 minus 8? -1 minus 8? -9. Right, that's where you got to remember that kind of detail about when you take square roots, you've got to put the plus or minus in there. Okay. Good. Okay, let's do another one. Convert this one. This one will be a little bit different anyways. Convert this thing right here to an exponential. What is it? Or sorry, to a radical. What's the index of the radical? The 4th root cubed, right? So that's just this part right there. You still got the 3, and you still got the 24. And then what? Divide by 3. The 4th root of x minus 2 to the 3rd equals 8. Okay, how do you undo a 4th root? Brianna? No, not this. Remember, for a square root, we squared both sides. For a cubed root, we cubed both sides. For a 4th root, we raised both sides to the 4th power. I thought I heard you say take 4th root. So the 4th root of x minus 2 cubed to the 4th power equals 8 to the 4th power. All right, so what happens when you take you raise the 4th root to the 4th power? Cancel. So we've got x minus 2 cubed equals, and you could put that in your calculator, what's 8 to the 4th? 4,096. All right, now on the last slide, we had to take the square root of both sides just to get at the x minus 2. What will we have to do on this one? Take the cube root of both sides. Right? The cube root of a cube is just what's inside. And what's the cube root of 4096? 16. Okay. So we undid the radical, and now we're solving this equation. One more step. Add 2. Okay, try to do the same thing with that one. Yeah. Yeah, 3/2. We've got an answer. I mean, what did you do to undo this radical? Square both sides? Okay. So square, square. X plus 1 to the third equals, what's 27 squared? Say again? 729? Oh, that's right. I remember this problem. Okay. And now, how do I solve for x since it's inside x plus 1 cubed? Take the cube root of both sides, right? The cube root of x plus 1 to the third equals the cube root of 729. Is that right? And the cube root of a cube just gives us what's inside. And what's the cube root of 729? 9. So what does x equal? 8. So I think there's one more kind of problem we have to deal with. All right. So far we've dealt with radicals, rational forms, but we haven't dealt with one where there was actually an x inside the radical and another x outside the radical. When you see that, that's when this check right here is important, right? And the others, if you checked and it didn't work, it's because you did something wrong, right? Because you should have gotten the right answer. On this one, it could be that it's an extraneous solution. It's actually not a solution. So you have to go through the steps, solve, and then just plug them back in. And if something doesn't work, then you throw it out and say it's extraneous. Okay, so let's see. First step, we have to isolate. What do I have to do to isolate that radical? Plus 5, right? X plus 7 equals x plus 5. Okay, now we have to undo the radical. How do you undo a square root? You square both sides. Right? The square of a square root, we just get what's inside. And then how do we do x plus 5 squared? No. That's not a properties of exponent thing. It's a FOIL. It's a x plus 5 times x plus 5. So we have to do the x plus 5 times x plus 5, which is x squared. Now, when you add 5 to both sides, it's positive. Is that your question? Okay. So when you FOIL that, you will get that. All right. So now we're at the point of we've undone the radical, and we have to solve the equation that's left. Well, you have to say, well, what kind of equation is it? Because that's going to determine how you solve it. Is it linear? What kind of a equation is this? It's quadratic. So you got to solve it like a quadratic. What are all the ways we had to solve a quadratic? Factoring, graphing, quadratic formula. In every one of them, we started out with everything on one side, 0 on the other. So let's at least do that part, and then we'll decide how we want to solve it. Right? Minus x minus 7 minus x minus 7. So 0 equals x squared plus 3x plus. Now that's not right. Sorry. Saying that's not going to work out. Plus 9x plus 18. Okay, So if we were going to factor it, that would be the simple quadratic because it has a 1 in front of the x squared. So if it's factorable, you ought to be able to find factors of 18 that add up to 9. Can anybody think of factors of 18 that add up to 9? 6 and 3, right? So this is factorable, and that's probably the easiest way to do it. I mean, you could use quadratic formula, 1, a is 1, b is 9, c is 18, and get the same answers, but it is factorable. That is x plus 3, x plus 6. So what are the values of x that make that true? Negative 3, negative 6. Okay, now we got to get to that last. Check those values because for one of them, it's not going to work out. Well, it can't say that. Sometimes they both work out, but you don't know until you check. So let's try. First, we'll try it with the negative 3. Right, that is going around here for the square root of negative 3 plus 7 minus 5 equals negative 3. Right, that's the square root of 4 minus 5 equals negative 3. That's 2 minus 5 equals negative 3. That's true. That checks. Right, try the other one, negative 6. The square root of negative 6 plus 7 minus 5 equals negative 6. The square root of 1 minus 5 equals negative 6. 1 minus 5 equals negative 6. Is that true? It's not true. Right, let me highlight that. Not true. Right, x equals negative 6 is extraneous, which means it's not an answer. It's not an answer. Okay, and it could still be one of those possible extraneous solutions when it's written in the rational form. Right, this one, the radical is written with a rational exponent, but there's still an x inside and an x outside. Right, so we have to change this to the radical. That'll be the square root of 5x minus 4, and I'll isolate it at the same time, equals x. Right, undo the radical. So 5x minus 4 equals x squared. Again, what kind of function do we have, or equation to solve? Quadratic. How are we going to solve it? Not sure. Let's get everything on one side, 0 on the other, and see whether that provides any clues here. Let me subtract 5x and add 4 from both sides so that I've got a 0 on this side. On the other side, I've got x squared minus 5x plus 4. Again, is that factorable? Are there factors of 4 that add up to negative 5? 0 equals x minus 4 times x minus 1. So x equals 4 and 1. Okay, and then what do we have to do? Check, right? And you could check just as well. Once you turned it into a radical, that's still a good place, right? So let's do that. That's 20. The square root of 16 equals 4. That's a check. Right? Try the same thing with the 1. The square root of 5 times 1 minus 4 equals 1. The square root of 1 equals 1. That's a check. So there's no extraneous solutions. They both checked. So let's see. Is that the last one? Yeah. Try to do the same thing with that. I think that was supposed to say you try. Right? So if you isolate, subtract 3. Square both sides. It's a quadratic. Get everything on one side, 0 on the other. It's factorable. The answers are 10 and 1. Right? The 10 works. 50 minus 1 is 49. Square root of 49 is 7. 7 plus 3 is 10. But the 1 didn't work. Right? The 1 ended up telling you 2 plus 3 is 1. That's not true. So if you want to write that down, we're going to have a quiz.